Welcome to class, everybody. We're going to start with lesson 5.2 today, day 1. But before we start that, I've got a joke for you. Why do all hot dogs look the same? Because they're inbred. Get it? Inbred. All right, verifying trig identities. Guidelines for trig proof problems are, number 1, use a Pythagorean identity when possible. Try to use that as much as you can. Number 2, change things into sines and cosines. Number 3, get common denominators and combine like terms when you've got fractions. And then number 4, factor when possible. So our first example, what we have is an equation, and you have to prove that one side equals the other. So I'm going to start with the more complex side, in this case the left-hand side, and we're going to try to show that it equals cosine squared. So I'm going to use a Pythagorean identity and change the numerator into cotangent squared. And now, after doing that, I'm going to use strategy number 2 and change things into sines and cosines. So the numerator can become cosine squared over sine squared. The denominator becomes 1 over sine squared. All right, we're trying to show that this equals cosine squared. The left-hand side has a complex fraction. So if I take the complex fraction and take the top times the reciprocal of the bottom, then we've got no more denominator. And this helps us because I can cancel this sine squared with this sine squared. And so it leaves me with cosine squared, which is what I wanted to show that the left-hand side equals. All right, we've verified that that left-hand side equals the right-hand side. Next one. This one will take a little bit different strategy to start the problem. We're not going to use a Pythagorean identity to start. We're going to show that the left side equals the right side. And I'm going to start off by changing things into sines and cosines. All right, so this allows us to cancel the cosine squareds. It gives us a 1 over sine squared. Still got the minus 1. And I like the way this looks because now I can change that 1 over sine squared into a cosecant squared. And that's a Pythagorean identity equal to the cotangent squared. And I've now verified that the left side equals the right side. Next example, this time the more complex side is on the right side. So I'm going to try to change the right side into the left side. And I'm going to use an A instead of an alpha. Let's change things into sines and cosines. And doing that allows me to cancel this sine of A with that sine of A. And so on the right-hand side, I'm going to be left with 1 over the cosine squared of A. Still got the minus 1. And I like the way this looks because we can change that 1 over cosine squared into secant squared. And then, of course, we can use a Pythagorean identity. Secant squared minus 1 is equal to tangent squared. And we've completed the proof by showing the left side equals the right side. Last one I want to do with you here, we're going to use strategy number 3, and that is take the two fractions on the left, put them together, and get a common denominator. Now when I do that, the LCD is going to be 1 plus sine of A times 1 minus sine of A. This is my LCD. We're trying to prove that the left-hand side equals 2 secant of A. Now, let's change the numerators. Since we multiply the bottom of the first fraction by 1 minus the sine of A, we do the same thing to the top, and I have the cosine of A times 1 minus sine of A. On the second fraction, since we multiplied the bottom by 1 plus the sine of A, we do the same thing to the top. Now I'm ready to put these two fractions together, and so since my LCD since I've got two binomials that are conjugates, I'm going to FOIL them and get 1 minus sine squared of a. I'm also going to distribute in the numerator, and so that's going to give me cosine of a minus cosine of a sine of a. Now into the second fraction, I'm going to distribute and get cosine of a plus cosine of a sine of a. Well, I like the way this looks because I can cancel this cosine of a times sine of a with this negative cosine of a sine of a. That leaves me with a numerator of like terms, 2 cosine of a. I should keep in mind we're trying to change this into 2 secant of a. All right. So there's my numerator. I'm also going to use a Pythagorean identity and change the 1 minus sine squared into cosine squared. And now I can cancel this cosine with one of those. It leaves me with 2 over the cosine of a. And I like the way that looks because that's equal to 2 secant of a, because cosine and secants are reciprocals. We've completed the proof, shown that the left side equals the right side.